Hello and welcome, guys. Today we're gonna talk about generative pipeline for heads and facial animation. That pipeline we would introduce for Dying Light project. And so maybe at the beginning we're gonna introduce ourselves. So I'm Maciej Zatwarnicki. I'm leading technical animation team in Techland. I'm also responsible for leading Techland's new upcoming open world RPG project. So maybe a few words about my career. So during my journey, I work on games like Hard West, Ancient Space, and also, of course, Dying Light 2. I also had an opportunity to work on cinematics, trailers, and cutscenes for games like Metro Exodus, The Division 2, God of War, and a few other. And also work on a couple movies like Another Day of Life and Wonder Woman. Together with me, I have Łukasz. Please, Łukasz.
Hello, my name is Łukasz Horzelski. I'm working on Techland as a senior technology programmer. Based on my experience is based basically on The Witcher 3 with all DLCs, also a bit of Cyberpunk and Far Cry 6, and the last ship title is Dying Light 2. Together with Maciej, we will host today's presentation.
At this point, I would also like to mention that this is not like just two of us did all of that pipeline. I would like to also mention about our team members, which were highly involved in concepting of this pipeline and implementation of it. I would like to thank Wojciech Kucia, Mariusz Julicki, and Błażej Kowalski for that. So before we start, we'd like to show you the final product use case. It's a cutscene from Dying Light 2. It's happened early in the game, so it's after the prologue. I'm hoping it's not going to be a big of a spoiler. We edited that cutscene so we can showcase some features, which we're going to talk about later. So let's play the video.
He's moving. Hack on. Kill him, Hack on. Kill him before I do it for you.
Oh, whoa. Relax. Breathe. Seems he hasn't turned.
Seems? Hack on, I don't want that here.
You've come back to us. Blink if you understand. Fuck my head. You were on the verge of turning, but UV light and inhibitors pulled you back. The bat helped too, of course. You're alive. Let's keep it that way.
Guy almost kills us all and you're chatting him up?
Girls, relax. They're frightened. You almost destroyed their workshop. We need to move out. Can you walk?
But I don't understand. Where are we going?
To a safe place.
I gotta get to the fisheye.
The fisheye. Without the biomarker, you won't get near it.
What the hell is that?
Biomarker monitors the disease's progression in the dark. That's your ticket into the city. Without it, stepping out of the light is sort of a lottery. You don't know when you'll turn. You need a biomarker, and I know where to find one. Come on.
Yep. That's the Dying Light, and we start with agenda. We're going to talk about asset creation, tools, procedural animation, engine implementation, and automated processes. So it's a lot of cover on that presentation, but we like to start with problem abstract. Why we needed that pipeline? Firstly, we needed talking heads, and a lot of them because it's an open world title. So just a lot of situations where characters gonna interact with each other, cutscene dialogues. But on the top of that, they're gonna scream, yell, and also bite because we have a ton of zombies, and that's what zombies do. On top of that, we need some form of lip sync. So that's another part which is gonna be necessary. We're gonna need shareable animations because in most cases in open world games, required to have some kind of shareability of content. In this case, we may have, for instance, the vendor who gonna reuse some of the dialogue lines in certain parts of the city, or we can have a situation where we want to try to concept some cutscene and reuse some generic NPCs and just build whole story, and at the end just replace visual representation for those characters. Yeah. Emotion visualization, it's another part which is necessary, but not only from a perspective of, yeah, we want to have emotions on the face. That's quite obvious, but we need to think about this more in the systematic way. So when we creating emotions, we would like to have library of emotions which can be reused during the production. Speaking in multiple languages, that's also important because our game was shipped in many localizations. So we need to have our animation of the faces in sync with audio as well. Flexible content changes, that's important when we have a longer production where you can at some point replace some of the part of the pipeline. For instance, if we're doing different topology or different LODs, we can replace a skeleton at some point. So the pipeline needs to be flexible enough so we can replace those chunks without having, redoing whole pipeline at that point. So it has to be flexible and content-driven. And fast iterations, which is also quite important because there's a lot of repeatable work which can be done either on the animator side or on the modeler side, which we'd like to speed up and just prepare the tools for them so they can work faster. And at the end, we needed to squeeze that all into all generations of consoles because at the time where we were finishing this pipeline, we were releasing Dying 2, that was more than 2 years ago. So our goal was to just make it work on PS4 and Xbox. Knowing all of that, we came up with a pipeline. So this pipeline is split into chunks, which we like to explain to you in bite-sized sections. So it's hopefully at the end gonna paint the whole picture. So I'll start with data preparation. The first thing which we'll need is shareable topology. In this case, it's important to have that. Firstly, we can quickly move the scan data to our topology, and later on, once we have more assets which are done on this topology, we can mix some elements of it. So in the future, once we build a library, this opens opportunity for us to build the tools based on that. So as I already mentioned, we can mix the content, but we can also define some areas on that topology, which later helps us to connect, for instance, our heads to the body, because as you see, a color line has to fit to the body at some point. So we can prepare some automatization to just wrap it into proper place for different body shapes. And on this picture, you see how we create a graph to move the scan data to our topology in Wrap3D. So kind of standard pipeline, but it's here. Another part which is important is shareable UV. Along with shareable topology, it's important to have that, not only because textures are obvious, of course, we're going to swap them in between for open world characters. It's quite common to use that. But shareable UV is crucial also if you prepare tools. So you can rely not only on the topology, but also on the UV space, which I'll later mention in one of the examples. Shareable add-ons. We also created the library of shareable add-ons for the heads. Those are, for instance, eyelashes, a shadow, a wet eye. Those are all the elements you can add to just improve the visual quality. There are also eyes, mouth interior, and so on. So for instance, in this example, we see eyelashes and a small tool which was created to wrap them around the newly created head. So you can adjust them and position them automatically and just see what you actually get as an end result. So this is the part where we prepare in the mesh. But we can, this mesh part is also important for further animation. So in here, this part of data preparation, which is still based on mesh, covers loops which will later on be important for animation itself. So the direction of the loops, amount of the loops, and all of the sections which you see here are very important for future deformation of the face. Because if you want to deform the face in a certain way, there are certain areas which just have to follow the anatomical deformation of the muscles, of the fat tissue, and just continue the movement to the direction. And that's how the topology supports that. On top of that, if you see those colored elements on the face, like colored sections, those gives us the borders between important deformation areas. Those are important in further part of the process where we're creating LODs. Those LODs, once we keep the important loops there, gonna still deform properly because we remain the motion of the face and the creases which we wanna keep, because the bones are positioned the way they can drive those loops. And one more important thing, which is done on this topology, are our blend shapes also split into channels. Those channels are driving the animation in the future. So for instance, for our pipeline, it was more than 100 channels. Each of them was having certain deformation of the face. For instance, mouth open, blink, smile, and all of that put together drives the animation. So all of that can be created on that topology. And in future, if we want to create different deformation for a certain face, we can just update few of the shapes and give someone his unique motion of the face. And now we are moving to a part where we moving topology motion to bone motion, because like possibly you guys already know, but for games we usually tend to not use vertices as an animation driver. We use a skeleton. So in here, first of all, we need to create a skeleton for animation, right? Because the bones are moving, the moving bones are moving the topology, and that's how the face is animated in most cases for real-time rendering. So in this process, as we have the face already in place and the asset is ready, and of course I'm talking about the base asset, so the fundament for the whole system. Now we need to place the bones in the proper position. So created the, let me play that video, short video. Yeah, and we created the tool which positioned the markers for the later bone spawning. That means that we just define the places where we want the bones to be, and we spawn the bones either in that position, or we have different type of markers, because not always bones supposed to be on the surface of the mesh. Sometimes the bones needs to be inside of the volume. For instance, lips. Lips cannot have they may, but they shouldn't have the bones on the surface. They should have them in between. So the rotation of the lips comes from the inside of the lip. In this case, we're using markers which are few markers, which then the position is averaged between them, and that's how we store that information, and that's how it's look like for that system. So once we run this process, we do exactly the same for that 100 few blend shapes which you saw on the previous slide, and this gives us so-called range of motion, which I will cover in the next slide, because we'd just like to sum it up because there's a lot of information here. So firstly, we write down all of the data, all of the information about where the bone's supposed to be. It's stored based on UV space. So that helps us in the future when we're moving that motion or spawning those bones on a different head. We know where it's supposed to go, right? Because we doing like reverse process of what you just saw on the new head. So next is skinning. So if you have bones already, you can also have a skinning, which can be either shared or generic. If you had shared skinning, you can store it as well. How we prepare that, we had some iteration on that. So once we position the bones, we're trying to generate some skinning and see how the motion looks like. Once we are closer to the position of the bones which we like, then we refining the skinning. It's more like hand work rather than generated, because generated skinning can cause some errors. And this gives us the overall range of motion. So all of those files are stored in our structure in the Perforce, ready to be used later on in actual asset generation. So this is the input for a whole system. So we start skinning, range of motion, position of the bones, information about skeleton. And in next slide, this one, we creating the asset itself. So let's look at it from the modeler perspective. If the modeler want to create a head in our pipeline, what he's doing? First of all, he's gonna get a scan data, whatever scan data he will get, of course of the head, because that's for the head, and use our preset mesh, right? So he's gonna take the base head and wrap the scan data to that topology. Then he's gonna spawn the add-ons, eyelashes, and all of that which I already showed. And he have a asset ready. Of course, he's gonna refine and resculpt some elements. He's gonna bake the textures because that's important for the visuals later on. But for the system to work, we are actually done once we have this head wrapped and cleaned up on our topology. So the artist export everything to one file. Then he goes to Maya, because in Maya, that's what I'm gonna show in a second. In Maya, we have a tool which let him pick that file from our structure and generate the head, which will be then used in the game. And overall, for what artist is supposed to do, that's end of his job, except submitting it to the purpose. So I'm going to play that video. And here you see the result of spawn, because in our process you not even see what's going on. It just, you just click, pick the file, and the head is ready. So in here you see the head where the bones are actually in the right position. This head already has LOD, skinning, and all of the channels ready to be animated. As you see here, yeah, all of them are already functional. So this asset is going to the engine, modeler can check it, see, connect the dialog lines to it and see how it works. If there's any issue, he can quickly fix something and do the same process. It's taking fairly 20 seconds to generate the asset once it's in Maya. What's important here, one of the last things I would like to mention in this process is we either can reuse the setup for generic NPCs crowds, so we have the setup for woman, man, child, but we also can prepare the custom setup, which works the same way, and it's a costless from the system perspective, and also from the performance perspective in the engine, because that range of motion is stored in one format. This is something which Łukasz will cover later in the presentation. But from our perspective, we can either do dedicated range of motion. If we have an actor which will have his own expression, and we want to move the expression to work with his face, then we can spend time on that, prepare those plane shapes, and just have that set up. And on top of that, all of those informations are just waiting to be picked by generator. And we have batch process. If we change something in the pipeline, for instance, we change topology or we've changed something in the skeleton, we can redo all of the heads for a whole project, and no one even noticed that it's done, because that data is still there and waiting for us to choose. So at this point, this is end of my part, and Łukasz, please.
Okay, so those changes Maciej mentioned required us to implement some responsive stuff on the file format. So changes were necessary basically on a wider spectrum to finish the requirements. So we had to extend our internal file format. We introduced some kind of data packing and compression under the hood. We implemented also special structure, basically a flow track curve to facilitate the motion itself. We also code bone pose elements during creation for poses itself to know which bones are responsible for which pose. This gives us special feature later on in the system. And the most important part, that this is stored in our internal format. So basically this data is decoded on the visual part. So basically for us it's free. Those changes also were necessary on DCC side, so basically on data content creation software. So based on Maya or other softwares, we had to introduce our own plugins, our own, I'll say, add-ons to store those extra information. So basically here we had the idea of metadata. We had to store those data in a special node. We introduced a special node in under the hood in Maya, and we store those data in a special node. So this gave us ability to process more data than we need to for automatic process later on. Those data were also necessary on builder side. So basically the builder for us was a server in the background running all the time, all day, all night. So we had to deliver continuous integration and continuous delivery system like safely. This had to be kind of like deterministic, that has to be efficient. So basically we had to enable this to be fast and reliable. That's why we also introduced the multi-threading on the content generation side. So basically we split the content into data chunks, we generate it in parallel, and later on we are happy to receive the results. This gave us some kind of like efficient and reliable flow once the results were acknowledged from the builder side. And the important part here is, we'll talk later on about this as well, that those builders were really important regarding the emotions. Because as you know, in many contexts on the game, you were able to have different kind of dialogue, different status, different state. So to fulfill the player's needs, we had to also fit the game's emotion. And those emotions were injected in two ways. One way was injected on the builder side, based on the audio, based on the spectrum of the audio. And later on, also it was also kind of like allowed for the users to implement their own emotions in the dialogue editor. So basically, if the end user or our narrative director was sure that we had to have specific emotions for the game, we were able to override it. So having this CI/CD, so this continuous integration system, reliable, deterministic, was really important for us. And also, it was really important to be reactive because we had to have really fast iterations and deterministic content on the end. So those emotion support was also kind of like in the middle responsible, like those emotions were applied by our manager, which was predefined for exactly this role. Pick up the emotions, apply the emotions, give us the status, give us the context of the game. This is those definitions. Basically, Maciej mentioned that we had UVs, that we had the topology, we had the bones, we had poses. Those definitions on the content sides really easy and really good facilitates the LOD system. So basically, those two components on the content sides created a module which we call the solid head module. It was responsible for in-game usage. And also we had a controller which was responsible for mixing those animation to basically see the final animation in the game, in the screen. So here, based on those definitions, we were able to really easily sample the animation with the knowledge that our LODs are almost for free because we had a bone on pose definition. So this was crucial to the system, that we defined those influences of bones on pose. And those definitions was really crucial for us to enable the really low LOD, really high LOD, with the performance later on. So we will see how fast and how reactive it was. To reflect this kind of animation systems under the hood, we also had abilities to override the system. like Maciej mentioned, we had kind of like a system, a template. Let's call it a template. We had a template, but later on, artists could be really eager to bump the quality of the animation. We have maybe some time, let's bump the animation. Let's maybe alter the animation by hand, like do a handmade. Those two things were totally possible because of the shadowing of animation files in our file system under the hood. So we were able to hide, cover, shadow the files with the content. And those went kind of okay in the final game, like you saw in the game itself. So all things considered here, we had those definitions. So kind of like responsibility was split in those, I'll say, 4 tools sections. So rigor, definitions. Rigor was responsible for definition. So we had to define the head itself. We had to define the pose. We had to define the bones based on the markers. Head, I mean topology. Animator was also was responsible for this kind of job, like Mocap. So we were able to override it on the motion capture side. For example, we have an actor to finish or store the lightness of the actor. It's possible to totally override the animation. So animator was responsible for this animation override, and also, there's a key point, was also responsible for emotion metadata. We showed you later on. But also, the procedural part on the continuous integration was also responsible for overriding the emotion metadata. So we were able to pick if we would like to generate this based on the audio spectrum or based on the user perspective, if we would like to have a specific emotion to guide the player. After the continuous integration kind of like picked up this emotion, we had a lip sync generator. We had, based of course on the audio and maybe optional text. So those processes were up and running under the hood. And in the engine, we had the solver, this controller, which basically solves all the metadata, all the emotions, all the curves, samples the animation, and picks it up to, in the game, in the corresponding LOD level. Something about the performance. So this system, of course, costs. But based on our calculations at Techland, we were able to measure it. So basically, the cinematic quality cost us 0.16 milliseconds for a system, and the minimal LOD cost us around 0.1. So the LOD flow was kind of like really, I'll say smooth. We didn't have some high pickups on the curves, so we were able to assume that this system at the final game will cost us something around this. So here in the end of this kind of like main focus, the few things was important. So the system was like the system had to preserve some kind of like things, some assumptions. So basically, as a summary, the system had to be data-driven. We switched the topology, like Maciej mentioned, resave. We switched the position of the bones, resave. We would like to add more bones to add more flow, resave. We like to have more quality, resave. So the system was responsible for last quick changes during the production time. So we know that this is kind of like happens a lot, right? That's why those predefined definitions were really important. So once settled, they were our key for modelers. This is the system, this is measured, this is how we will go with the flow. You like more? No, it doesn't fit the system. So we did this kind of assumptions. And those assumptions work really well in a templated environment. Thank you. So this is our approach for this, and if you'd like to have some questions, feel free to ask us.
This is the perfect time. Any question? No? Okay. It looks like this is the end. Thank you
If
so
you'd like
much.
to add some questions, we will be downstairs.